in terms of this lab, I think it's always best to just, let's go ahead and get the puns out of the way first. Yes, it's going to be a crappy lab. And yes, they are kind of a pain, and as I was saying, we should go ahead and define suppositories if we're going to make them. So the whole point to them is they start off as a solid. You're sticking a solid something in somewhere. And again, there are multiple orifices. Today, the dry lab will be making a rectal suppository. You guys in lab will be making a vaginal suppository. Yes, they even do make urethral suppositories, which are smaller and just kind of disturbing to look at. But basically, if there's an orifice in the body, you can insert something solid into it to deliver a drug, and that's what a suppository is. Let me ask you, it goes in solid. Does it need to stay solid? Do we want it to stay solid? We do not. What do we want it to do? Well, it can do a couple of different things, and what it does will depend on the base. The important one, this is very important because the understanding of just the two main bases that we're going to be talking about in the lab, we'll talk about storage, we'll talk about what to expect in terms of when you insert the suppository. There are two main types. There are oleaginous bases, and cocoa butter is the model for that. We're not going to be using cocoa butter for our dry lab. We're going to be using a cocoa butter substitute called fatty base. We used to do cocoa butter in lab, and it was great. It made the lab smell like chocolate. It was awesome, all right? But it was a pain because how do you have to melt it? You have to melt it really slowly, and we had to use water baths, and that was a real disaster. That was a pain. It took a lot of time. It wasn't worth it. So, thankfully, they invented fatty base, which is like cocoa butter, but it's more what? What is the advantage to the fatty base? It's more heat stable. So you can use a hot plate, still on low, and do it carefully, but you can use a hot plate to do it much more quickly, so before it polymorphs. Because, again, if you overheat cocoa butter, or even fatty base, if it gets overheated, it won't re-solidify. So they work really good, they're non-irritating, and they work really well for rectal suppository. So if you're going to make a rectal suppository, you would use something like a fatty base or an oleaginous cocoa butter base, because it doesn't irritate the tissue. All right? How does cocoa butter work? It starts as a solid, you insert it rectally, and what does it end up doing? It melts. It melts and liquefies at body temperature, certainly above room temperature. All right? That's one kind of base. The other base that you're actually using, what is the base are you making for your wet lab today? It's not a fatty base, it's not an oleaginous base, it's a PEG base, polyethylene glycol, right? Did anyone remember what the brand name is that you'll be using? Polybase. You're going to be using polybase. It's a very different type of base. It works the same way. You melt it, you put your drug in, it re-solidifies, and it's great. What is the advantage of the PEG bases, certainly from a compounding standpoint? What is it? Why is it going to be so much faster for you guys to use the polybase today than even a fatty base? What are you going to do to melt it? Microwave it. Again, it is very heat stable. You can still eventually burn it, but you can microwave polybase, which means it's going to take you 30 seconds to do something that might take several minutes otherwise. So very nice and convenient that way. Here's what's really important, though. When you insert these, they do cause some irritation to rectal tissue, so they don't make very good rectal suppositories. They make better vaginal suppositories, particularly because they don't melt. What do? They dissolve in body fluids, and it takes a fair amount of fluid. That's why, again, they don't work very well in the rectum. They work well for vaginal. Vaginal fluids will dissolve it and do that. So in the end, so good. Knowing the two different bases is important because it has to do with storage, and you will have to be putting auxiliary stickers on the exam. So what is one of the auxiliary stickers you're going to put on a fatty base? If I give you a fatty base to use as the base, what storage sticker do you put on there? Keep refrigerated. What storage thing do you put on for the polybase? Does it really matter if they're cold or hot? Because they don't melt, so is there any problem with sticking them in the fridge too? Yeah, why? What's wrong with the air in the refrigerator? High moisture, and again, we'll dissolve them in the refrigerator. So again, we want to say keep it room temperature. So, all right, bring that up. I know you're excited, but that's important. All right, the way you're going to make this today is the fusion method. It's so simple, even I can do it. You know what it is? You melt it, you sift your drug in, you pour it into a mold, and the mold fuses it. As it solidifies, it shapes the thing. And you make really cool, you'll see today, your suppositories are shaped perfectly, they're nice and shiny. The only issue you'll have to work at is, are they the right size and weight? But beyond that, the making of them is very straightforward. Okay, we're going to use a mold to do that. All right. So, the compounding is very easy. The calculations are hard. That's the disadvantage to using the fusion method, because you need to understand this. This is the disposable mold. You'll be using an aluminum mold. But either way, when you pour into a mold, would you agree this mold has a fixed volume? It has a certain volume of liquid that you can pour into here. So you are going to be compounding by volume. All right? But how do we dose drugs? Do we dose rectal or vaginal suppositories by volume, or we dose them by what? weight. They're dosed by weight. So we have a problem here that's leading to this whole discussion about the density displacement factor. So here's the deal. I could pour this all the way to the very tippy top with liquefied base, okay? Now, if I started to add some of my drug, and I put drug into that very absolutely full liquid volumes cavity, what would happen to the base as I put my drug into it? What will the base do? Spill out. Would you agree? It has a fixed volume. If I put drug in, base will come out. An equal amount of what? Whatever amount of drug I put in, I will displace an equal volume, not necessarily an equal weight. And that's why we have to take into consideration the differences in density between the drug we're putting in and the base that's coming out. We displace equal volumes, but we are measuring things by weight, not volume. So that's why we have to use this density displacement factor. It relates the weight of two different things, a drug to its base, it compares the weight for the same volume. And we'll use those in calculations. So I will tell you, and it is what you're going to be doing on the exam, I will on the exam be giving you density displacement factors, which is nice. It makes the procedure easier, but it makes the calculations more difficult. You need to understand this. So we're going to do this here in the dry lab in a minute together. Make sure you understand it before you leave lab today, because those calculations are what's going to be certainly on the exam, because it does make the procedure then easier to do. Lastly, at the bottom, I want to make sure you understand, for me and certainly on the exam, you're going to prepare and do your calculations based off of excess, and we want your excess to be a minimum of 4 extra suppositories. Trust me. And I'm sorry if I confuse you in the lecture. USP 795 says if you're a good compounder and you know what you're doing, you can get away with 2 extra. Are you a good compounder who knows what you're doing? You are probably not yet, okay? So trust me, if we want to avoid tears in lab because it dried up, I don't have enough to pour the number to dispense, do it for 4 extra and that won't be a problem. You should have no problem getting at least the amount to dispense if you've made enough goo to make 4 extra suppositories, all right? So bear with me on that. Make sure you do that for the exam as well. All right, that's enough background. Let's get into the practice. Get out your calculators. You're going to be, again, we're going to need to do these calculations. This is the best practice. This dry lab, one we're doing together, definitely does a better simulation as far as the calculations and the process for your exam prescription. So as we're kind of getting that stuff ready, let me read and interpret the prescription with you. Georgia Elder, and she is an elderly patient who is needing some indomethacin 25 milligrams, along with some combined with ondansetron 4 milligrams, and we're going to put that in a fatty base suppository because we want to administer it rectally, and that seems to me it's a good base choice for a rectal suppository. All right, fill out the formulation record down below as I'm kind of talking, so you can kind of get that stuff out of the prescription. Anyone have any idea kind of why you would need that? Indomethacin is kind of an anti-inflammatory. Clearly the ondansetron is going to help with some nausea, so it's probably some inflammatory bowel disease things that's going on, and somebody who's got some of those problems that they can't tolerate that orally. So again, you know, NSAIDs can be difficult on the stomach. So let's bypass all of that and treat their inflammatory bowel disease kind of using a rectal suppository and combining a couple of drugs together that don't come together combined. Okay? So the doses and all that seem reasonable. Okay, so you kind of filled out the formulation record. Now that's very important. Let's look at the additional information. A couple of things. The top line about the calculate for 4 extra suppositories. Circle that, and I'll remind you, I will not give that to you on the test. I expect you to do it, and I expect you to remember that. The heart of what you need to know is that you don't just compound for the precise amount. You are going to do excess, in this case 4 extra. Okay? The rest of this stuff I will provide you, but you'll need to know how to handle it. I will direct you to what type of molds to use. As I remind you, these are kind of disposable plastic molds. The ones you're going to be using today in lab are kind of reusable aluminum molds, so I'll clarify that, and I'll just tell you now, on the exam, you will be using the aluminum molds, the same molds you're using today. Part of the reason we're doing what you're doing today is so that you'll learn how to use those molds. So you will just get to replicate that process on the exam. I want to make sure you know how to do it. But we'll tell you which molds to use. This is important. For whatever mold you're using and whatever base you're using, in this case we are talking about fatty base, you do need to know a calibration value for it. You need to know what a blank base only suppository that comes out of that mold, if it was trimmed to the same level that you're going to dispense your real ones of it, how much would that weigh? So I will give you a calibration, and in this case for these plastic molds using fatty base, a blank base only suppository out of that mold weighs 1.9 grams. And it's an important number. You're going to see we're going to have to use that here, and I will provide that to you. All right? Now, you can also see I'm going to provide you DDFs, density displacement factors, for each of your ingredients. Active ingredients as well as excipients. And we'll get to why we need to know about excipients, because what is our source for indomethacin? It's not indomethacin powder. It's what? Indomethacin capsules. Okay. What about ondansetron? It's not from bulk powder. It's from an 8 milligram tablet. So I'll just remind you going back. Do you think an 8 milligram ondansetron tablet only weighs 8 milligrams? No, that would be like nothing, right? So there's a kind of a bigger tablet. There's a bunch of other stuff in it. So whether it's the stuff from the capsule or the stuff from the tablet, if it's not active drug, it's what? Excipient. And so I do give you, and again, it doesn't matter where the excipient comes from, we're going to say that the DDF for all excipients from commercial products have a DDF of 1. So that's why you've got 3 DDFs. You've got one for indomethacin, one for ondansetron, and one for the excipients that are coming along with those commercial products. Okay? And that's really the bulk of the important information. But there's a lot of important information from that. So can you kind of digest that and kind of see what all that information means? Okay? All right, we're going to use that here in a second. So let's look at our ingredient list. Let's go ahead and kind of look at this first. What are the actual supplies in our compounding record? I filled it out for you, lot, expiration, and all of that. We're going to be using 50 milligram capsules as our source of indomethacin, 8 milligram tablets for our ondansetron, and then fatty base. All right? Now, since we're here, let's go ahead and do, I always like at this point, go ahead and calculate our beyond use date, or determine the beyond use date, because you can see all the expiration dates there. Go ahead and circle which one of those has the one with the shortest expiration date. Okay? So I'm going to circle that. All right? So what would that date be? That would be 8. What does 8/2019 mean for an expiration date? It actually means what? 8/30 of 2019, right? So August 30th, 2019. So is that your beyond use date? That's the shortest expiration. Or what is it? 6 months? Ooh, it's not 6 months. 6 months was for what? Powders and capsules, but we're now down one level because we are now taking our powder and mixing it into a molten base that then resolidifies. It could have possibly introduced a small amount of water, so we're more conservative. So we drop from 6 months down to what? 90 days, 3 months. So what is 3 plus 3 of 2019? Because we're still in March, right? So that would be 6, and what is today? 29, right? 6/29 of 2019. So is that shorter than the August 30th? Absolutely. So let's put down June 29th of 2019. Everyone get that okay? You should have your beyond use date of 6/29/2019 on there. All right, let's drive on to the calculations. So turn to your calculation section. Because there are a lot of calculations and they can be confusing, I've gone ahead and tried to put as much typed up there as possible instead of my awful handwriting. So I will fill in the blanks with you. It is extremely important that you do these calculations yourself. I'm trying to train you to do well on the exam. So let's start with this. Very important thing here. It's not hard, but remember, when we base our calculations, we are going to be dispensing how many suppositories? 6. But we are going to base all of our calculations now on 4 additional, so that's why make sure that we use 10 suppositories for all of our subsequent calculations, okay? Make sure we do that. All right, let's pick a drug. Start with indomethacin. How much indomethacin, pure indomethacin, would I need to be able to compound 10 suppositories that each have 25 milligrams each? So certainly 25 milligrams per suppository times 10 is what? 250 milligrams of indomethacin. Right? Now, let's go ahead and figure out how many capsules we need, because we're going to go ahead and have to get that. So we need 250 milligrams, and they come in 50 milligrams per capsule. So if we just take 250 milligrams of indomethacin divided by 50 milligrams per capsule, how many capsules do we need? 5 exactly. Well, that's convenient. You happy? That's good. So we don't have to set up the whole proportion thing and calculate a ratio or anything else. We need all 5 capsules worth. That's good. Do the same thing for the ondansetron. I know some of you are running ahead, and that's great. I'm trying to make sure people can follow though. So if we do the same sort of thing for ondansetron, 4 milligrams per suppository times 10 suppositories would give us 40 milligrams, right? If they're 8 milligram per tablet, and so 40 milligrams divided by 8 milligrams per tablet, do we also get 5 tablets? So, once again, we're still going to be using these commercial sources, but we need the entire amount. We need all 5 tablets and all 5 capsules worth. We don't have to set up the proportion. But what do we know about those commercial products? They're not just indomethacin ondansetron, there's also what in there? Excipient. Do you know at this point how much excipient? What do we need to know before we could calculate and determine how much excipient? What do we have to do? Weigh those products. So that's Judy's going to come up here and she's going to do those weights, and we're going to need to write those weights down. All right?
Densitron is a tablet. Let's measure the tablet first.
Does she need to crush up the tablets before she weighs it? No. Good. Now let's write down 0.497. 0.497 grams represents the weight of 5 ondansetron tablets.
Indomethacin is a giant capsule. Here first, open 5 of them. Some of you guys might be opening them better than me now.
Judy said that you guys were tired of me messing with you, so she's just opening these capsules. Would have remembered not to just weigh the 5 capsules? Is that right, though? Because we don't want the weight of the 5 capsules. We want the weight of the what? The powder contained in the 5 capsules. Idea, though, just weigh the capsules.
Right, last one. Bear with me.
We'll write down 1.962. 1.962 grams for indomethacin. Thank you, Judy. So now, what are we going to do with that? Well, from each of those, go ahead and subtract the amount of active ingredient in that weight, because we do know precisely how much active ingredient is in there, and therefore the difference between the weight Judy just weighed and the active ingredients will be the amount of excipients. So I'll do mine, you do mine, you do yours, and we'll compare numbers here in a minute. I'm going to encourage you to do your own work and put these numbers in there. This is your practice for the exam. Once you've subtracted from each drug to find out the amount of excipient, the last step on the slide says to go ahead and add those together. Because in the end, in our dispensing process, our calculations here, it don't matter whether excipient came from indomethacin or whether the excipient came from ondansetron. In the end, we need to know all of the excipient that's going to be into this suppository. So, again, I took my 1.962 milligrams of indomethacin, subtracted the 0.25 grams, that's the active ingredient, and got 1.712 grams of excipient from that. For the ondansetron, the weight was 0.497, subtracted 0.04 or 40 milligrams, and got 0.457. Add those two together. In the end, circle this number, or make sure you, as we go forward, this is the one we're going to need, because like I said, I don't care where it comes from. In the end, and again, if I make a mistake on my math, please correct me if I screw something up. I got 2.169. That was my total for all excipients from both of those ingredients. Okay. So, do we know the weights of everything going into our base? Do we know the weight of the indomethacin? How much indomethacin? 0.25 grams. How much ondansetron? 0.04 grams. How much in the excipient? 2.169. But guess what? Now, none of that matters. what we need to know is not the weight of drug going into the base, but we need to know the what? The weight of the base being displaced by that. Does it make sense? So we are going to be putting those weights of drugs into our liquid base. Our next step is to calculate the weight of base being displaced by that drug. So these direct weights don't matter in our next calculation. We have to convert them. That's where the density displacement factors come from. And so I set them up like this. I think sometimes it's easier to visualize or understand what a DDF is if you kind of set it up this way. But here's the deal. I want to make sure you understand. On the exam, I'm not going to give, there's no units. For indomethacin, the DDF is 1.2. That's all I'm going to tell you. DDF equals 1.2. So this is an important skill, that if I say 1.2, that you can set it up this way and truly remember and understand it, that the 1.2 means 1.2 grams of what? Drug. In this case, indomethacin. It's 1.2 grams of indomethacin for every 1 gram of base. And the 1 gram of base is implied as the denominator. So 1.2 means 1.2 grams of indomethacin per 1 gram. And what goes on the bottom? Of base, per gram of base. So let me ask you, and those two numbers represent the weights that occupy the same volume, okay? So which one is denser? The methacin, right? It has more weight per the same volume, okay? Just realize that's what you're doing, is for the same volume, it's comparing the two different weights, the weights of the drug compared to the weight of the base, all right? Same thing for the ondansetron. I gave you the DDF of 0.9, so you set it up as 0.9 grams of ondansetron over 1 gram of base. And excipients, I will tell you now, will always be just 1 for us. So if it's a DDF of 1, then it's 1 gram of excipient displaces 1 gram of base. Okay? And I'm writing this down before I forget. It was 2.165. All right. So now, set that equal to. So we'll go back to indomethacin. We know our DDF is 1.2. 1.2 grams of indomethacin per 1 gram of base. Set that equal to, do we know how much indomethacin we're putting into the suppository? Yes, 0.25 grams. So equals 0.25 grams of indomethacin on top over X. And X represents the weight of fatty base displaced by the 0.25 grams of indomethacin. So solve for X, take 0.25 divided by 1.2, and go on from there. I'll shut up, go ahead and do this math, set this up however you want. I'll give you a chance to kind of write this out though for yourself, your own notes. Make sure you can do this later on the exam, but solve for those numbers. Tell me, for each of those 3 ingredients, how much fatty base is going to be displaced by the amount of drug we're putting in. Is there a vibe of confidence or boredom? I can't tell which. We're doing okay. This is the kind of the key concept. If this concept makes sense to you, the fact that if you determine how much drug is going in, the next step is convert the amounts or weights of drugs to the weights of the base displaced by those things, you're golden. That's really the hardest part to doing DDF calculations with suppositories. And it makes the procedures really easy once you understand that. Can I go on? Is everyone okay? All right. So, our next step, really there's just one last step left. This is an important one to understand. Remember I told you I was going to give you that calibration, and this is why it's such an important value. Because what we need to know is, in a suppository, what would the weight be of just base? Okay, we said the calibration for these molds and fatty base gives a suppository that weighs 1.9 grams each. That's great. How many are we making? 10, because of all of our drugs were not for one suppository, they were for all 10. So we're going to take that 1.9, multiply by 10, and that's the total base we would need. In the end, we have to have 19 grams of base. All right? So how much actual base do we need, though? Because some of our drug will be displacing that base. So start with that total weight of 19 and subtract. Now, this is the trick. Are we going to subtract the weight of the drugs? No, we are subtracting the weight of the base displaced by those drugs. Those are the numbers we just calculated using the DDFs. So do you remember, what was the value for the indomethacin? It was 0.21 grams displaced. Okay, for the ondansetron, it was 0.044 grams displaced. And the excipients, because it had the same weight, was the 2.1, what was it, 68? Gosh, short-term memory. 69. Right, so you do that, I do that, we gotta get new numbers. You guys get that value? We're going to be moving on here in just a second. This is your last chance to ask me questions on these calculations. It's awesome you all seem to be getting it. That's great. Now, let's go back, though, and fill in our compounding record. So, because now we know some things right over here. So, your target amount for the fatty base is going to be, what did we just say? 16.577 grams. And how many capsules are we going to actually use? 5 capsules. And we're going to have 5 tabs. How come we don't have another line for each of the tablets and capsules for the amount of powder? Because we're using all of the powder from the capsules and all of the tablets, so we don't need a separate line. We are using 5 capsules worth of powder and 5 tablets, obviously, so that makes a little bit of documentation okay. Everyone okay with that? All right, so now turn to your procedure while I try to get Judy here in 3D. All right, sweet.
Okay, so we measured both ondansetron and indomethacin already. The only thing we haven't measured yet is fatty base. And you are going to measure into a 100 ml beaker directly. Okay, and what is my target weight here?
The target.
16.577. Wake up, everybody.
Out there. Better than yesterday's where they were complaining about it.
Keep sleeping then.
All right, so write down for your actual for the fatty base at 16.623. So our actual was 16.622 for the fatty base. Now, why is the fatty base graded? Does it really matter? It doesn't come that way. We had to grade it. Why did we grade the fatty base? Won't it melt either way? But if you have a big chunk and a little chunk, which one melts first? The little chunk. And while you're waiting for the big chunk to melt, what does the already liquefied little chunk do? Polymorph if it overheats. Does it make sense? We want it to melt the same. So when you go do your polybase out there, realize when you microwave it, it's certainly more stable, but it's still, don't have just one large chunk or a big chunk and little chunks. Try to make them about the same so that they do melt more consistently. Just a good technique in general.
All right, so we probably don't really need the balance anymore. Set your fatty base aside, and let's now come back to take care of the ondansetron, which is a tablet. All right, so you guys know really well the term. What am I doing right now? Saturation. Make sure that you use the right term. All right, I'm using my rubber spatula to transfer all my powder together. Okay, based upon the estimation of how much powder do I have there already versus how much indomethacin I have way more indomethacin than. So what do I need to do now? What is it? Another term. I need to do geometric dilution now. So I probably need to do about twice minimally Okay, 5 minutes later, I did my first dilution and the second one. Well, in the exam, you cannot just say 5 minutes later, okay? Right? Okay, so this is all set. What is the next step?
Next step on here says to place the indomethacin / ondansetron powder into a sieve that is in a medium weigh mode.
Okay.
Why do we use a sieve? You'll be using a sieve also for the wet lab. You always use a sieve when you're adding your powder to your molten base. Is a molten base really, really thin, or is it still a little thick? Still a little thicky. I mean, it's not super thin like water. It's molten, it's liquefied, but it's not really thin. Powder would very easily clump together if you just dump it in all at once. So we want to disperse the powder. We don't want it clumped. We don't want uneven concentration through that. So we want to make sure that it stays relatively even. See, I'm just trying to make sure. I'm still thinking a little bit. I'm the cameraman here. I apologize. You can tell with my skills on the videos, it's a little questionable.
All right, so we are not stirring yet. We're gonna heat to medium heat, okay? And this is going to take about, usually 50 or 60 Celsius degree will be good enough for fatty base. And you don't want to go further up because you don't want to form the polymorph there. And this is probably going to take about 20 minutes for this to melt. So once you melt a portion on the bottom, you kind of stir a little bit, keep melting until it's all melted in the end. Meanwhile, for that 20 minutes, of course, you can go ahead and prepare your suppository. So for the dry lab, we're going to use a plastic one. All right, the plastic one don't quite sit. Therefore, you need a stand on the bottom. And you can slide in the plastic one and sit like this. Okay. Now, the plastic one, what's handy about the plastic one is, if I can, doesn't quite show well. Okay, that's why we probably need a cameraman. Anyway, the point here is hopefully you guys can see that there's a line here. Okay, so that means on the top here is the overfill. All right, therefore when you pour your suppository liquid in there, you do not necessarily have to overfill all the way to the outside. You only needed to pour somewhere close to the top because, oh, that looks better. Did you everybody see the line there? So this is your overfill. Okay, as the liquid congeal, it's going to actually shrink a little bit and typically cause a little bit hole in the right middle. Therefore, you want to overfill to the very top. In the end, when it actually becomes solidified, you can actually cut the top off. Therefore, the bottom one is the actual product you can dispense. Okay, all right, so that's about the plastic shell. Of course, the other thing is make sure that you actually observe both sides, okay, and then make sure that there's no dent. For example, this is something I chose for last week. All right, it looks very fancy from one side, but if you look at the other side, you may see all those dents there. If I pick a model like this, then my product will look like that when it comes out as well. All right, so that will be another thing to pay attention. Okay, so let's set up. Okay, by sliding and set this on the side. Okay, 20 minutes later, liquefy.
We actually rehearsed that.
We rehearsed a couple times. All right, so now we are going to add a stir bar.
So you want to talk about the numbers on the different hot plates?
I haven't done that yet.
Okay, so you can tell here, some of you have hot plates look just like that, where you turn the dials and it has numbers. Some of you have slightly older ones that just have like 0 to 10. So that's why the look on the procedure, it will give you either a number setting, like a number like 4 or 5, or it might give you 60 or a larger number. It depends on which hot plate that you have. They both work just fine, but that's why the settings may have different numbers.
So your procedure process medium speed. Technically, you can go even above medium speed as long as you don't cause any spill. All right, you probably want to do actually a little bit quicker than the medium speed, but don't cause any spill.
So we're on step 8 there now, and that's where it says setting of 4 or 60 degrees. You can kind of see that on there. So once melted, turn off the heat, add the stir bar, and begin stirring in the base at a medium rate.
Okay, as you can see there, some of the drug actually accumulate on the top of the stir bar.
We'll turned off the heat.
All you need to do now is just lift up and then shake a little bit so the powder can come up. And keep sifting in there. Again, you wanted to do a little slower than I do here probably, because I do see a little bit powder chunk formed on the top there. Alright, and even though we triturated, but there's a little powder particles formed on the very bottom, and you can use your metal spatula, try to sieve them to the bottom. If there is a lot, if there's still some, and you can just toss all of them in the end. Remember that we collect in the weigh boat. Alright, so the sift has a little bit powder which goes through the sift. So we're going to add that part into the base as well. Okay, and then I realize I still have a little bit on my stir bar. Okay, so we have added all the powders in there. Now what we'll do? We are ready to
Carefully remove the beaker and the product from the heat source, place it on the countertop, and begin stirring continuously with a glass rod, allowing the mixture to cool for just a couple of minutes until you can hold it comfortably by placing it on the palm of your hand on the bottom. So
all right,
if it's so hot it goes out, that would be too hot.
Okay, so of course we don't want to have the stir bar in there because it's magnetic, so you can use your spatula to lift up. At that point, you should be using your glass stir rod, okay? And because we didn't really go to very high temperature, so it's not really burning hot. As long as you feel it's comfortable, it's not going to melt my plastic mold. That means I'm ready to pour, all right? So remember we prepared our plastic mold at the very beginning. Okay, I'm ready to pour now. So before I pour, I want to give it a very good stir. Okay, I want to make sure that my drug particles are evenly distributed.
Now, does she have to overfill these? Yes and no. She pours it just to the very top, because the very top on these molds has the overfill. Remember that little line difference? So if you just pour them to the top, it is overfill. Your aluminum molds, you are going to have to overfill to where they spill out over on top of the mold.
So as you go into somewhere in the middle, you probably want to stir again because some of the particles may precipitate to the very bottom.
A little bit easier with aluminum molds, but it's still a little bit of fine motor skills. Some people were appearing a little stressed yesterday because you spent a lot of effort to try to get it right, so you got to get it into the molds and get them filled to the correct level.
So remember, we calculated for full access. Technically, I could have pulled maybe one or two more, but because I know my skill, I know that all my 6 will be good. So I'm probably just gonna pull 6 there. What should I do with my access? Remember, those are liquid right now, but when they congeal, they will become solid, and I don't want them to clog our sink. Therefore, I'm going to collect all my waste into a weigh boat, let it congeal there, and in the end, when it's solidified, then I can trash them in the regular trash. And you should do the same thing as well. Okay, so we finished the pouring into the mold now, and this is going to take another, how long does it take to solidify?
A minute or two? No, 20 minutes. You really do. For you guys, even on the wet lab, that's the problem for you. It's kind of like a hurry up and wait lab, because it does take 20 minutes. If you pull them out or try to take them out before 20 minutes, trust me, they will be so soft, they will still kind of stick to the mold, and they'll ruin them as you try to open it. So you do need to let them congeal for at least 20 minutes.
Right. The most common mistake we will see from students is that you rush a little bit, and as you open up, you realize it fell apart because it's not completely solidified yet. All right, so this will take about 20 minutes. All right, 20 minutes later, you don't get to write this procedure, right? 20 minutes later, 5 minutes later. So this is our 20 minutes later, all right? Finally, it's solidified already. Okay, we can take out from our mold there, and we can observe, look very good there. All right, so I'm ready to prepare this for my patient. So that's one of the suppository. Okay, I'm going to open from the bottom. And this pull them apart doesn't take that much skill, but you need to make sure that your both hands pull them equal amount of force, because otherwise you don't want to create any chip or divots at this point, because this is your final product.
Suppositories are relatively soft and malleable. If you take your finger and push on it, you will dent it or deform it as you're trying to unmold it. So. Do not use your imagination.
All right, so one of them is ready. But remember that we had a little excess on the very top, right? So even from here, can you see the line? So the excess, the line is over here. All right, can you guys kind of imagine it's there? There's a line there. Okay, and then underneath the line, right? Underneath, we're not going to use it, by the way. Underneath the line here is you're going to dispense as a suppository, and on the top here is the access. All right, we said at the beginning, this one doesn't show the hole on the very top there, but you're probably going to see that on your own product. As they solidify, they kind of retract and then form a little hole in the middle. So anyway, we're going to cut right here on the line. All right, and this is a piece of final product I can dispense for my patients.
It does have a little dent in it. Can you see that little dent on the tip part of it? And that's why, again, being careful and select ones that don't have it on there, because they come out dented if they start dented. So what would you do with that final suppository? There's two possible things for dispensed suppositories. You can wrap them individually in foil, because certainly you don't want them to rub and lose their drug. They can stick to each other. They can stick to other things. So you can wrap them individually with foil, or what a lot of pharmacies now use, what they call cardboard suppository boxes. And those have dividers, and those dividers are wax lined so that the suppositories don't stick with them. So we can assume for this, we would be dispensing that into a divided suppository box. That's kind of what we would say to do that. Okay? This. All right, well, let's drive on. So they're made. Yay, we're not done dispensing and doing all of our documentation. So let's finish up with our documentation. What are you going to have to do? And this all applies for what you're going to be doing in your wet lab today. Your QA final weight or volume is not individual weights like they were for capsules. We want you to calculate an average suppository weight. So stick a weigh boat on there, hit tare, put all of your 6 suppositories that you're dispensing, and take that weight and divide it by 6 and tell me what your average suppository weight was. Does that make sense? So your average suppository weight. Okay, you'll have to calculate that. Not difficult. Should it be kind of close to the mold calibration? Yes, it may not be exact, but again, if a base only is 1.9, then the drugs can throw it off a little bit, but they should be relative to that. So you should be somewhere kind of close to the calibration curve, just so for your information. So we have an average suppository weight there. Your visual description has to include color, some description of color. So I said off-white. It has to have some description of opacity, because believe it or not, like polybase actually solidifies relatively clear. If you don't have much drug in there, they come out almost clear based, even though they're kind of waxy. So again, this one was completely opaque. So we described it as opaque. Okay. Something about the texture on the outside, smooth. And yours will all come out smooth thanks to the mold. The mold makes a very nice and shiny, smooth suppository. You'll see that. So the smooth, okay, suppository. And then you do have to describe the shape. So in this case, we could call it a pointed tip. It was also, this mold also has kind of we could describe it as a bullet shape, because it has kind of a pointed tip. There are special suppositories, rectal suppositories, brand name called rectal rockets. You know, why does the shape of the suppository model matter, especially for a rectal suppository? Because you want to push it in. What do you want to do? What do you want it to do when you push it in? You want it to stay there. So they're shaped to help minimize the chance for it to be ejected. So again, the shape is somewhat important, and sometimes you choose a mold specifically for that shape. Okay. So anyway, so some description about the shape of the suppository. All right, we did the beyond use date already, so that should be straightforward. And like I said, we're going to assume for this example that we're going to be doing it in a divided suppository box. Lastly, for storage requirements, refrigerated or room temperature, I forget which is which. Why is this one refrigerated? What determines it? Is it because it's a rectal suppository? No, it's because it's in a fatty base, oleaginous base that melts at above room temperature, so we want to keep it in the refrigerator. So this one would be refrigerated. Okay? The last thing is drug name, strength, and dosage forms. Pretty straightforward. A couple of things that will make sure you understand, though. 2 things. You can lose points. You're going to have the drug name and the strength. That's easy enough. 2 things. Do not put the name of the base. So the fatty base or the poly base for you guys that you're going to do in a little while, does not go in the patient's drug name. It doesn't go on the label. Okay, it's part of the formulation. It doesn't really add to the final product, so it does not go in the drug name. Also, for the dosage form, you cannot just say suppository. I will take off points now. It either needs to be a rectal suppository or a vaginal suppository. It must indicate the route along with the dosage form. Okay, so make sure you include that. And then lastly there, just remember the 2 auxiliary stickers. There will always be 2 for the exam. It will be storage, either room temp or refrigerate. And again, you can't default to room temperature. You clearly indicate either room temp or refrigerated, and then you remind them of the route for rectal use only or for vaginal use only. So there are going to be 2 stickers depending on what you're doing. Make sure you give me both of those. Are we ready? Okay. Let's look at your wet lab. This is the one you're going to do. Hopefully you watched the video on this. It is a little bit labor intensive. But the fact that it's labor intensive belies the fact that the calculations are a piece of cake. We're going to do them together. They're so darn easy. There's nothing to them. So let's look at this. So why is this one different than the one we just did? Prescription for Lily Hansen. She needs some zinc oxide, 100 milligram vaginal suppositories. Okay, so we're going to formulate this in polybase, which is a good base for vaginal suppositories. We need to dispense 6 of them. All right. You can fill out the formulation information down below there. Zinc oxide is kind of a protectant, so this will help kind of prevent irritation, itching, discomfort that you may be experiencing, and so forth. So that's a good product to use, therefore, in a vaginal suppository. All right? Look in the additional information. I tell you to remind you today to calculate for 4 extra. Tell you you're going to use the aluminum suppository molds and that a blank polybase suppository trimmed to the right level that comes out of your aluminum molds weighs 2.3 grams. Okay, an important number there. Problem is, what I don't give you is a DDF. Since you have no idea what the DDF is, how can you calculate how much base is going to be displaced by your zinc oxide? You cannot. You have no idea. So you have to do a different procedure. You have to pour them in a way such that you don't have to worry about the amount displaced by the drug. So therefore, we have to use the double casting method. So when would you use the double casting method? You would only use it when you what? Don't have a DDF and don't know how much base is being displaced by your drug. On the exam, I will give you a DDF so you won't have to do this method. Why am I making you do this method? A, so you know where a DDF comes from. Today, you will be calculating your DDF from this experiment. You'll be being able to calculate a DDF for zinc oxide and polybase. Plus, in this method, you have to liquefy a base, sift a drug, pour it. Wait, liquefy, pour it, wait, and trim. You get to do all of that stuff twice. So by the time you leave today, you should be pretty comfortable in pouring and trimming suppositories using these molds. So when you do this on the exam, piece of cake. All right? So that's the rationale. Let's do these calculations together. They're super simple. So let's start with number 1. Let's calculate the amount of zinc oxide we will need. How many suppositories are we going to dispense? 6. How many extra are we going to calculate for? 4. So we have 10 suppositories. How much zinc oxide per suppository? And I'm going to convert to grams here, so don't freak out here. It was 100 milligrams per suppository, right? So that's the same as times 0.1 grams. So what is 10 times 0.1 grams per suppository? That would give us 1 gram. 1 gram. Guess what? Zinc oxide comes as a bulk powder. So what are you going to actually have to weigh? 1 gram. That's all you have to do is weigh 1 gram of zinc oxide powder. All right. Now I'm going to go through the technique here in just a second, but to do this, we need to also put our polybase separated into 2 different glass beakers. All right. In the first glass beaker, we're going to want half of what we would predict we would need. Okay. What do I mean is how much, do you remember my additional information, how much did a single base-only suppository weigh? 2.3 grams, right? So if one suppository would be expected to weigh about 2.3 grams, and I'm making how many? 10, then I would predict I would need about 23 grams total of polybase. But in my first beaker, I want only half of that. I want to make sure I don't have anywhere near the total amount I might expect it to need. So let's take the 23 that I might need and divide it in half. So I'm nowhere near that amount. Okay? So 23 divided by 2, and then bear with me, I'm going to round a little bit because it doesn't have to be exact. Let's go ahead and round that to 12 grams. Okay? So I are going to, in the first beaker, put 12 grams of polybase. All right? Beaker number 2, we need just a bunch of excess polybase. So I don't need an exact amount, but let's go ahead and take the amount we put in beaker 1, which was our 12 grams, and multiply that by 2.5. So what is 12 grams times 2.5? Around there a little bit, but we're going to essentially do that to 30 grams. Beaker 2 is going to have 30 grams. Guess what? That's it. We're done with the calculations. 1 gram of zinc oxide, 1 beaker with 12 grams of polybase, another beaker with 30 grams of polybase. That's pretty much it for the weighings and the measurings. All right? Any questions about that? That is what you're going to be doing. All right? So I'm a little bit concerned. Let's go ahead and fill out your compounding record, though, since we've just done those. You can go ahead and fill that out. It should look like this. This is the best way to kind of write it out there. You can fill in the manufacturer and lot and all of that. But you're going to have 1 entry for zinc oxide powder. We said our target amount is 1 gram. For polybase, there's going to be 2 beakers. Beaker 1 with 12 grams and beaker 2 with 30 grams. Got that? So, let's talk about the procedure here. Let's see. Go ahead and on your procedure, let's do this first. Just make a couple of notes here. Put a big old star by number step 14. See where there's that fill in the blank under step 14 where it says to write down the weight? That's extremely important. What's going to happen, you're going to go through a bunch of work. In the end, you're going to have these suppositories set up for 20 minutes, and they really do have to wait for 20 minutes. After 20 minutes, you're going to trim them. I'll talk about that here in a minute. And you're going to remove 10 suppositories. They won't be your final suppositories. They're all messed up. You can't use them yet, but they're trimmed to the right weight. So put all 10 of those suppositories on a tiered weigh boat and write the weight down. You need that weight to be able to calculate a DDF. So put a star by step 14. Make sure before you remelt those suppositories that you document the weight. Okay? So what I want to do here is I'm hoping and I'm assuming you all watched the exciting video. And I want to make sure point out just a couple of things so that things don't go really bad for some of you out there. Okay, because this is technically a little more complicated.
The required equipment.
All right, so do remember out at the stations between you and the person across from you, I've already set a jar of polybase, so you don't have to go to the supply stations, but you have to share with the person across from you. So you got polybase there. There should be 2 aluminum molds. So grab one of the aluminum molds, do open them up, and just take a paper towel and dry wipe them out. Just make sure there isn't stuff in there already, because if there's some particles in there already, where do those particles end up? In your suppository. So just clean them out quickly. Don't get them wet. We don't need to spray them. Just make sure that they're clean and dry. There isn't any junk in there. Then re-put them back together. All right. Then you're going to weigh your zinc oxide. So on your procedure real quick, step 2, look at your procedure in your handout where it says step 2, pre-sift some zinc oxide. Cross off pre-sift. It's pretty fine and you'll waste your time. So you don't need to pre-sift nothing. Just weigh 1 gram of zinc oxide. That'll just make life a little bit easier. Not a big deal. So you go get and you'll have your 1 gram of zinc oxide and you'll put it in a weigh boat. Then here we are putting our 2 beakers. Put a circle or note this, whatever step it is there. 100 milliliter glass beaker. See that glass beaker in the video? Those are the 2 beakers you need to use. Are they small 100 milliliter glass beakers? I can always tell who doesn't listen to me because somebody just yanks out the big tall 400 mil. You think it's a glass beaker? Who the hell cares, right? Well, you go microwave it and then you're like this. Pouring, 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 and it's slowly coming down that big long glass thing and you can't get hardly any of it back out. So trust me, there's a reason for this. Use the small glass beakers for all your steps today, okay? For both of the ones here and the whole procedure. You're using this, okay? So in the end, would you agree, you've got 1 beaker with how much? 12 grams, 1 beaker with 30 grams, all right? What are you going to do? You're going to go over to the microwaves in the middle. You're going to put them both in there and microwave for how long? 30 seconds. Can you believe I made you watch all 30 seconds? Anyways, in the video. All right, so you're going to microwave it for 30 seconds. And then you're going to pull it out, all right? Obviously, one of them is going to have less liquid than the other one. At the stations, I only have blue food coloring, but I have a drop of blue food coloring. I want you to put 1 drop of blue food coloring into which beaker, though? The small one. The blue color is supposed to represent the drug, all right? Because that's the beaker the drug's going to be, and it will help you visualize your rinsing and your attempt to get all of the drug out of the beaker and into the mold. That's the only reason we're doing it. Would you ever normally add a drop of food coloring to a suppository formulation? No, that's awful. People don't like color coming out of there. So no, we don't want food color in a normal product. The only reason we're doing it though, it really will help you visualize the rinsing as you're trying to get all of the drug out of that beaker and into your mold. That's the only reason we're doing that. But remember to add 1 drop of food coloring to the small vial. All right. Then, this is an important setup. Then you go back, you get your hot plate up, you turn on the settings to what it says in the procedure. You're going to put the stir bar into the small one with the blue food color and put it right in the middle. Take the excess beaker and put it in the back of the hot plate to keep it warm. We don't want it to solidify. And in all of this here, you're fighting time a little bit. This is what I mean by it's a hurry up and wait, because you're going to have to wait for 20 minutes. But you got to kind of hurry up and get there, because as soon as you take that molten base out of the microwave, what is it doing temperature-wise? Cooling, and as it cools, it solidifies, and if it solidifies, you can't add drug or pour the stuff into the mold. So we have to do this part relatively quickly. That's why hopefully you kind of visualize these steps and can progress through them. Anyways, get that stirring as fast as it can without going crazy, and then you sift in your drug, just like Judy did in here, okay? Don't dump it all in there, but make sure the stir bar does a good job of getting all of that stuff dispersed in there, okay? Then you're going to take it off of there, remove the stir bar, and then you're ready to pour, okay? This is what's really, really important. Your small beaker with all of your drug, you've got your empty mold. First thing, how many cavities are in your aluminum mold? 12. How many suppositories did we calculate for? What is the first mistake you could possibly make? Start pouring across all 12. So I would take a piece of tape if I were you from your, you got tape in there for those parchment papers, and cover up the last 2 holes. Whatever it is, make sure that you're only going to do it into the 10 suppository molds, the cavities. Having said that, at this point, it is really important you understand the idea behind this method, since we have no idea how much base this drug displaces, that you underfill 10 suppository cavities. We don't care how much is in each one. It doesn't matter that they're the same, but they're all underfilled. So this has got to be, you got to take this pink drug, and this in the video, yours will be blue, back and forth across 10 cavities that all remain as low as possible. You want them evenly dispersed, but below the level of the cavity, okay? So you can see here, she's going through and pouring, but none of them are getting to the top, okay? However, she's now poured everything out, but is there still a bunch of colored goo left in the beaker? Because it's already starting to solidify. So we want you to rinse. And so make note of this in your margin. Do not rinse more than 3 times. You will still have drug left in your beaker. It's impossible to get it completely clean. And some of you, that drives you crazy. And you try to rinse, and you try to rinse, and you try to rinse, but you rinse too much, and then you overfill the cavity. So no more than 3 total rinsings. And make sure the amount that you rinse with is a very small amount. Because your rinsings also need to be divided between those 10 cavities, so that it's still below the top of the cavity, never even with your rinsing. And so here she is rinsing and pouring, and rinsing and pouring, and she does it several times. But do you see right there, those second 3 in a row are too filled up? Would you agree? You can see that the rinsings are almost to the very top. So even that wasn't really well done. It would be better that they all look kind of like this first one, and these ones here, you can kind of see there's stuff in there, but they're not that high. So making sure you don't over-rinse and don't use too much of a rinsing volume as you do it. Do it 3 times at the most. Then what do? Then you go back and set that aside, and you don't worry about what's left in that vial. You grab your other clear one with your excess, and this is where you fill it up here. And this is important here. You see how this is spilled out and formed kind of a mushroom head. It's spilled on top and kind of gone onto the metal mold. And now it's not spilling and dripping off the sides or anything on the counter, but you want to make sure, I keep doing that you overfill those enough. I can't emphasize that enough, because when she's done and we set that aside, what's going to happen over time? As it solidifies, it will contract. And as Judy talked about, that's where those holes come in. And if it contracts, if you just fill it to the very top and don't overspill it, it contracts down below the cavity. And I'll take your word for it. It was at the top when you poured it, but by the time you're done, it's below the top of the cavity, at which point your suppository is underweight and doesn't have enough drug in the case. So we want to make sure that it spills out and over. And then you have to wait 20 minutes, okay? And you can see what it'll look like 20 minutes later, all right? So that's when it'll be ready to go. We're ready to trim it. Should there be any blue on top? Do you see where it's all white there? Why? In the case, I know we did pink there, because all the pink, all the drug is down below, and we overfilled with the excess. That's what it should look like, all right? Now we need to trim it. This has still been problematic, because we want to be able to trim it off and also polish it on the top. So make sure you use, and this is important, a large metal spatula, okay? Do not stick a plastic or rubber spatula on there, as it will melt, okay? That's a bad thing, right? So the first thing you're going to want to do also before you do anything out there is, we've set out all the hot plates and there are stir bars on top. Just stuck on top of there, so take the stir bar off, don't lose it, set it aside. This lab will take a lot longer if you don't plug it in. So plug in the hot plate or it ain't gonna do nothing, all right? They never get hot, so make sure you do that. They do get hot, okay, so I had safety. I'm a little bit worried about you. I'll be careful. As soon as you turn that heat thing on, it will get hot. Respect the heat on top and be careful as you're moving and manipulating it all. Also, take a damp paper towel before you do anything, and sometimes even between steps, and wipe the top carefully. Again, because anything, any wax or anything that's on the spatula here in a minute, or anything that gets on there will start to smoke and stink really bad. If that happens, let me or Judy know. We'll clean it up, but we don't want you, and we may not know, and don't be breathing the toxic smoke. Let us know. We'll clean it up. And it helps before you even turn it on, kind of make sure it's clean and nothing will smoke. Large metal spatula, because you want as much metal surface area as possible to be hot. And again, it's magnetic, so you can just kind of set it on top there. After a little bit, flip it over, but have the heat on medium-high setting, okay? And I would hold it off and don't slap it on your hand, right? That's a bad idea. But hold it close. I mean, if you get your hand close, it should radiate heat. If it's not radiating heat, then it's not going to do and help you melt the base as you cut through there, okay? And you do more of a samurai chop, and it makes chunks come out. So it's better that it's nice and hot. You know, it doesn't have to be on fire, please. But again, warm. I can definitely feel heat coming off of that. And then I just want to make sure you watch. This is a little bit tricky. Do you kind of slice back? Let me kind of back up just a little bit here.
Go ahead and use it.
And it's a sawing motion, a little bit back and forth as you're pushing. It does take force to push it off, but it's a little bit back and forth, and you can see the heat from the spatula is starting to melt that.
While you're trimming, it's melting some of that base and filling any of the divots.
And you see where you then pull some of those shavings back in, put your hot spatula on top and rub it in a circle, and what does it do? It melts it and fills it in on top, polishes it, and keeps any chunks or big holes from being in. You can fill in small holes that way. You can avoid problems with being chopped off there. So again, you'll get twice to be able to practice that, but it takes a little bit of effort, okay? In the end then, you'll have it all nice and trimmed, you'll remove it, and that's what they should look like. They should have different amounts of color in all of them, but there should be a little bit of blue in your case in all 10 of those. You're going to carefully remove those into a weigh boat and do what with it? Weigh it. You need the weight of those 10 suppositories. That's how you'll be able to calculate the density displacement factor. Could you dispense those to the patient? No, they all have different amounts of drugs in there. So you do need to have 6 to dispense, right? So do you have to start all over again? Oh, hell no. What are you going to do with those? Can we reuse those? We can reuse those. So, I mean, I don't know where it is in there, but if I stick all 10 of those into a glass beaker, again, a small glass beaker, stick them in the microwave for how long? In your procedure, it says 20 seconds at this point. Melt those for 20 seconds. Boom. Do you see? Then stir them up real good. You see how it's all nice and uniform now? So now you've got a nice even concentration. You can pour that into the molds for your final casting. And I will still say this. When you go to do that, how many do you need to have to dispense? 6. You have enough goo to make supposedly how many? 10. Remember, and the whole problem is if you don't overfill them, they pull down and you can't use it. So it's better to have 6 overfilled than 8 all underfilled, because then none of them are any good. And that always historically happens. So remember, as you pour through these, make sure you go back and forth for the first 6, and back and forth until they looks like that. See what I'm saying? To where it's spilled out like a mushroom all the way across there on all the different sides. And then try to do one more at a time. And then maybe one more at a time. It doesn't do you any good to have a partial filled mold. If you're not going to have enough goo to fill up a full one overfilled, then just use that to overfill the remaining ones. Okay? So get 6 really good, and then one more at a time until you can do it. Wait for the time, same sort of trim, and you're going to essentially then put them in there, give me an average weight, and that's it. Now, let's just say you did an awesome job, and you have 7 beautiful suppositories. How many are you going to bring over to me? 6. You remember you were going to compound excess, but you're not going to dispense excess. So make sure in the end, your final weigh boat, since we don't have the boxes, will have the 6 proud parents of these suppositories. All right? So, having said that, that's enough of the procedure. Let me just go back real quick. I'm trying to be quick here. I don't know. A couple of last things to say about that. Okay? So, my point being, what are you going to do for the 20 minutes? You'll have 2 20-minute dead times. So clean up as much as you can, and you do need to, again, pour any of that excess polybase, as Judy said, into a weigh boat and let it set, and we can just trash it then. Use hot water and soap to clean out your glass beakers as you need. Then here's what I really recommend that you do. I have posted the errors and omissions. Would you agree in your packet there are those last 2 pages are the errors and omissions? Now you think, I don't care because it's not on the test. And you're right, it's not on the test, all right? But the errors and omissions for this dosage form involves DDF calculations just like it's on the test. So if you want to just take pictures of the errors and omissions, that's fine. If you've got some dead time, try to work through the errors and omissions, and particularly for maybe the calculations, you can check yourself and see if you can catch the errors that I made on that. It will help you for the test. That is something that you're going to be tested on. So one thing you can do during the first 20 minutes. During the second 20 minutes, that's the time that you're going to fill out the other sheet. Did you notice there's a DDF worksheet in there? And so you need to fill that out. In the end, calculate that. Then have Judy and I come check that before, while you're still waiting. You'll get that done while you're still waiting for some minutes. So have Judy and I check it so it makes the final checkout even go faster. So that way you don't have to wait to show us at that point. So you do need to fill the DDF on that. Finally, that's all I got to say. Why are you still in here? Let's go out there and do it. Please ask Judy and I if you have questions or problems. Please respect the heat of the hot plate. Any issues, missing equipment, let us know. Let's go out.